So this is our agenda. Your test, I believe, is April 14th. Your homework's still due on the April 11th. You have a review today, and then you'll have another review in class on Monday, I believe. So, any questions, comments, concerns? Yes, no? Okay, guess that's fine. And so, have you seen the test yet? From what I'm sure, I don't think she's made it yet. I can check right now, but I don't think she's made it yet because the last test, she made it like not the day of, but nearly almost. She made it very close to when you guys had the test. So it was like the day before the test she made it to get everything in there because it's been like a few days. So I think she makes it within like new every year. Oh, okay. Well, yeah, this one's pretty fast. Along like stoichiometry though is a lot like dimensional analysis. It's just taking parts of little content. Yeah, the test she didn't really teach. Okay, well, yeah, that's unfortunate. I can't really help with that because I'm not Dr. Kelly, but I'm sure you guys will be fine. It's just a lot of math, I think. Like, exam one and two is a lot of like conceptuals, as you might have remembered, but like three, four, and five, it's a lot of math. It's just a lot of math. Well, she drops the lowest, I think. She replaces it with the final, so don't be too discouraged. 67. You can still replace it. There's still time here, so you don't have to worry if like you failed one thing. A lot of teachers like they just replace it. So yeah. So it's a 30 question practice exam. I think because this is like 1 hour, I'm only gonna do I think I have like maybe 15 questions on here because we're doing it as a group. And what I'm thinking is that we're gonna do okay, so what you can do is that when you see the questions, you can do them individually by yourself, or you can go along with me and we'll do it together. So you can do that depending on what you like. Because some people go really, really fast and they answer it really fast, but there's some people who don't. Yeah, so I'm gonna go through it all together, so you don't have to worry, and then we'll check like what you got right or wrong. This is from my practice test, and a lot of the questions I had on there were on my test. Dr. Kelly's tests are like they're very, very different. She's a very interesting teacher. I'll just say that. Um, Anywho, so this is a study guide that I had, and you can just see everything. So I would suggest knowing every single thing in every section, basically writing, balancing, stoichiometric calculations, limiting reactants, percent yield. I know for sure she's definitely gonna have like find the limiting reactant more than just percent yield. Balancing tends to be pretty easy, but know how to do hard ones because teachers know you know how to do easy stuff because it's easy. So they do like harder ones on there. Stoichiometric, again, it's very similar to just dimensional analysis. So, and then you also have, I believe, 7.5, and then 7.6. So just know how to do that. Again, empirical and molecular, you have to know how to do stoichiometry. Like they all pretty much connect. Percent composition, you need to know that to do empirical formulas. So they all kind of like go together, pretty much. So I don't think we have any questions, so I'm just gonna get started. Oh yeah, and the 7.7 and 8.1 is also on there. There's not that much to combustion analysis. There's not that much. So yeah, okay, first question. Which set of coefficients correctly balances the reaction? When you see this, what do we get? Does anyone want to say like what do we do first? Like what's the first thing we do? This one's actually pretty easy. So is there anything you notice that you would do first when balancing this? How much there are of each. Right, so, okay, what elements are we balancing then? Looking at this equation. Like tell me what exactly you would state out. Balance it first, P and O. Okay, yeah, you're right. So P and O is definitely something that you would look at first because it's all together, and this only works if it's already as a polyatomic ion. So instead of just doing P and O, like you would see on this side of the equation, I would say just link it together as PO4. Because on the other side of the reactants, it stays as PO4 and doesn't change, right? You only have PO4 2 over on the other side. So I would suggest just keeping that the same. And so you have 2, right? We have 1 over here. So how would you balance that? What would we do? Does anyone know? We have 1 on this side and then 2 on the product. So what would we do to the whole compound of something? What would we do to it? Does anyone know? Yes, no, I don't know. The answers 2 in front of okay, so if you put the 2 in front of that, now K equals 6, right? And then PO4 is balanced to the other side. But then something else has been balanced too, right? So what do we do next? Because K is now 6, right? So what do we do? What's the next step? Does anyone know? Put the 6 in front of the, okay. So once we've done that, we have, okay, so both the PO4s are balanced, the Ks are, the CLs, this has 6, right? And this only has how many? On the reactant side, Cl, how many does it have? 2, right? But we have 6 on the product side, so what are we going to multiply that times? 3, exactly. So once we do that, what's our correct answer? As you can probably tell from the list of things. B, right? Exactly. So do we all agree we all got B on this? Is there anyone that got something different? Or is confused, like, oh, I don't know how you got B. Okay, I agree. Okay, nice. So let's keep going. That one was pretty easy, I think. So let's go to the next one. The expression for pentane C5H12 burning in oxygen is this. What set of coefficients balance the equations or equation? So what do we do here? Does anyone know? What should we be doing here? What's the first element or what we're going to do first? What are we going to look at? What compound? Can anyone tell me what that would be? C5H12, O2, what are we looking at? Does anyone know or can answer that question? What are we looking at for our pentane here? 1, 2, 3, or 4. Which one are we doing? Does anyone know the answer to that? You don't know, just write I don't know. A. Okay. And then how did we get A then? A, okay. How'd you get A? What did you balance first? What did you look at first? Carbon. Yes, exactly. And why do you look at carbon first? Why did you not look at oxygen? What's the difference? How come I can't start with oxygen? Or why is that like a bad idea? Because it's odd on the left. Okay, all right. Does anyone else have something else? Like, why would we start with CH versus just going with oxygen? Because it's alone by itself, right? So wouldn't it be easier to balance? Why is that? Why do we do CH first? Does anyone else know or have an idea of why? If you don't know, just write I don't know. Because usually, yeah, exactly. So I would say that whatever. Yeah, because usually when you have something on the other side, you can see the products you have oxygen, right, in both of the compounds. So it's going to be harder to balance because it's not in just one compound, it's in both. Versus CH, it's just one compound and each of them are separated on the product side. So it's easier to balance those to do first versus oxygen. Because if you have one element and it's like scattered throughout the products, it's harder to balance because you have to make it the same at the end of all the products, right? So it's easier to do CH first. And when you do that, H is what? H is, do we keep it the same or do we just keep it as one? One or what? Yeah, can anyone tell me what that is? Balance it. What do we get? Do we just keep it the same or no? Yes, no, I don't know. Does anyone want to answer that? Keep the same. Yeah, exactly. So it's just going to stay one, right? So what you're going to do is you're going to, yeah. So for this, basically, if you have H and you have 12 and you have 2 on the other side, what can you multiply by to get 12? 2 times what to get 12? 6, exactly. So you multiply this times 6, and then you have 12, bam, equal, right? Which means, but it's connected to C, right? So you have to balance the other side with 5. 5 C's, right? So once you do all that, how many oxygens do you have on the product side? Once you multiply all that, right? What? How many oxygens? 16, right? Okay, so we have 16 on this side, but we need 16 on this side. That's the great thing about doing oxygen last, because now you have how many oxygens do you need? Now that you have O2 on this side, 8, exactly. So once you do all that, bam, it's all, there you go, it's just A. And we all agree, we all understand how we got that, A. Yes? Okay, very nice. Okay, that one's pretty easy. Just have to start with CH first. Okay, next one. And that's A. How about this one? A 4.042 gram sample of hydrocarbon upon combustion in a combustion analysis apparatus yielded 6.484 grams of carbon dioxide. The percent by weight of carbon in the hydrocarbon is therefore what? So this one is a combustion analysis problem. So because of this, what are we going to do first? We have two values. We know it's combustion reaction. So what are we going to do? What value do we start with? Does anyone know? What are we going to start with? 4.042 or 6.484? What are we trying to find here? Does anyone know? Yes? No? I don't know. So does anyone have, you don't know? Okay, does anyone else know? No? Okay. Or what? First, right? Okay, I think the first number. Okay, so a lot of you guys are saying the first number, but that's the thing. This right here, the 4.042, just because it's first doesn't mean that's the one you want to use first. Just because it's first. Because as you can see, this one just represents a hydrocarbon. Okay? So, like, because from this you're finding the carbon, right? But you're given carbon dioxide. So this will only be helpful once you already have the weight of the carbon figured out. Like this doesn't do anything. 4.042 doesn't do anything until you have the carbon dioxide figured out. Yeah, so basically you need the carbon dioxide, the weight of the carbon figured out first before you use the grams of hydrocarbon. Because you can't just start with one without the other. You can't do that. So you start with 6.484. And what are we going to do with that? We have grams, right? So what's the bottom? What are we going to do next? What's the bottom value? Molar mass, right? So what's the molar mass we're using here? What's that going to be? The molar mass. Can anyone tell me what that is? 44.04. Okay. Yes, correct. And that's carbon dioxide. Yes, exactly. Yes. So 44.01. So we have grams of CO2. What's the top value going to be? Does anyone know? 1 mole. 1 mole of what? 1 mole, 1 mole. CO2. 1 mole of CO2. Okay, so you definitely could do that, but there's also a faster way of doing it. So you could, but we can do it that way. We can do 1 mole of CO2, right? So what do we put on the bottom then to have it match? The same thing or something different? 1 mole. 1 mole. Okay. Actually. Okay, so you guys are making it more complicated than it needs to be. So for this, all you genuinely have to do is not put this is actually making it way harder. For this problem, all you genuinely need to do to put on top is something else. Not 1 mole, not, yeah, you have to put grams of carbon, but you don't need the mole on top. So what will we have on top here? Instead of 1 mole CO2 or 1 mole carbon, what are we going to get? Grams of carbon on top, and what is that going to be? Once we put grams of carbon on top. So, yes, exactly. So, yeah, don't make it harder than it needs to be, I think. You guys are like thinking really hard for it, but it doesn't need to be. Yeah, that's pretty much it. You just multiply that out, and then what do you get when you do that? 6.484 times 12.02 divided by 44.01. What do we get? 1.77, right? Okay, and so did everyone get that? 7.77 when you multiply that? Just want to make sure everyone got that. Yes? Okay, so what do you do after you get that value? So you have the grams of carbon, right? So you found the weight. What do you do now that you have that? Divide by 4.042. Do we all agree with that? Do you divide by 4.042? Or do you do something else beforehand? Yes? No? Anyone else have anything else to say? Do we all agree you divide? Or do we do something else? Do mole ratios. Okay. Okay, does anyone else have anything else they want to say? So we have divide, do mole ratio. Anyone else? Yes, no, I don't know. You can just write that if you don't know either. I just want to have someone else say something because there's like 12 people here. So, you don't know. Okay. So you have to do the weight of hydrogen in the hydrocarbon, right? Actually, no, you don't. So for this, you're just gonna, what Akash did was great. You're just dividing by 4.042. And when you say you have to do the mole ratio, you're thinking about empirical formula. That's when you do the mole ratios between it. Like, oh, this one has the smallest divided by this, and then, yeah. So you wouldn't need to. So I found that. Okay, so after you've done that, is that your final answer? There's no decimals like that, right? So what are you gonna do once you found that answer? Akash, because you got point ratios. Okay. Times 100. Multiply, yes, exactly. So once you multiply that times 100, what's your final answer? Someone got C, someone got something else. What's your final? 43.79. Okay. Do we agree? Did someone get something else? Yeah, SmartWorks has like a weird way of working with things that I really just don't like. They make it more complicated than it needs to be. C. Okay. Yes. Percent yield. Yeah, it uses both the combustion analysis because it uses carbon dioxide and hydrocarbon, but you are finding the percent of weight, so take it as it is, yeah. So same. But yeah, it's gonna be C. And did we all understand how we got that? Pretty easy, right? Like you don't have to do like the mole CO2 and stuff like that. Exactly, there you go. I think SmartWorks made you guys think things are harder than it is, which is inconvenient. Okay, a compound contains arsenic and oxygen as the only elements. Only elements. A 1.626 gram sample of compound contains 1.060 grams of arsenic. It's probably just like a rounding thing. If you got 0.79, you'll be fine because it's just 0.01 off. You're gonna be fine. Don't worry about it. So this one, if you have a sample and you have 0.060 arsenic, what's the percent composition by weight? What is the calculated empirical formula for the compound? So there's two parts to this question. Pretty much, you're doing percent composition, and then you're gonna do and find the empirical formula afterwards, right? So, what are we gonna do first? Can anyone tell me? Does anyone know what we're starting with? Yes, no? So what are we gonna do first? What value are we looking at? Does anyone know? Yes? No? I don't know. Someone confused? You guys sound confused. Or, I don't know, I can't really tell. But like, is there something, like what do we do first? We're looking at this problem. We have this sample of 1.626 and it's, so, yeah, so the sample all in all is 1.626. We have 1.060 grams of arsenic in this entire sample. So from this, how do we find the empirical formula? That is a lot to think about in a short amount of time. Moles, exact. Okay, so how do we find moles? What value do we start with? Do we start with the 1.626? Do we start with the first number and mole to mole ratio? Okay, so you guys think we start with the first number. Okay, do we all agree? 1.626? Yes or no? 1.626, yes. Do we agree? Do you guys think that's correct? Okay, and then we all agree with this, right? Yes, no? Can I get someone in the chat to say, like, what they think? Or if you don't know, you can just write, I don't know. Just some feedback of any sort. Yes, I don't know. Okay, so actually that'd be wrong. Actually, what you're going to start with is this value. Because, yeah. So 1.626 is the whole sample. And that's what I was talking about when I said it's arsenic and oxygen. You're using both, right? This whole sample has both arsenic and oxygen. They only give you the grams for just arsenic, which means you have to find oxygen, right? So you're going to start with 1.060. And I think it was a cost, you said moles. Yeah, you have to find the moles first. You're going to find the moles of arsenic because that's the only value they give you. 1.626 you can't do because they didn't give you the value of oxygen from that. So you're gonna start with arsenic. So with that, how do you find moles from this? 1.060 grams of arsenic. What do you do next? Can anyone tell me? Or do you divide? What do you do? Molar mass, right? Okay, so what's the molar mass of arsenic? Does anyone know? If you don't know, you can just Google it. That's what I do. Instead of like taking out my periodic table, which I already have here, but like if you don't know, you just Google it really fast. Like, what's the molar mass of arsenic? Can anyone tell me? 39.948. Okay, do we all agree with that? Arsenic? Sorry. Yeah, that's supposed to be 74.9. Chad, I think you might be looking at the wrong website or something. I don't know. But yeah, it's supposed to be 74.92. So that's definitely a weird answer. I don't know where you got that. But once you do that and you divide it, what do you get? Yeah, that's probably why. So what do you get when you do that? What do we get when you divide 1.060 divided by 74.92? What do we get? How many moles of arsenic? Yes, exactly. 0.14. And if you go a little further, it's 2. So I'm just going to do that just for rounding purposes. So now you have the moles of arsenic. What do we do next? We have the moles of arsenic. What do we do with that? Or what do we do next? Does anyone know? Can anyone give me a value? Like, oh, we do this or that, or what do we do? Can anyone tell me? Yes, exactly. So once you've done that, so everyone agrees, right? That now they have the moles of arsenic, you don't have anything else to work with because you don't have oxygen. And those are the only elements used in this whole sample. So you have to subtract the 1.626 minus 1.060. So once you do that, what value do you get? Can anyone tell me what do you get from that? What value is that gonna be? 5.66, yep, exactly. So once you get 566, what do you do with that? So now you found the grams of oxygen. So we're gonna do the same as arsenic, right? You divide by 32 on the bottom. Why 32? Why 32 on the bottom? Do we all agree with that, 32? Diatomic? Okay. A mass of O2. Okay, actually, you're gonna divide by 16. Yep, T is right, it's 16. Nowhere in here does it say O2. There's no O2, it only says arsenic and oxygen. So you have to assume that that's it, and you're starting at 1. You're not starting at O2 or O3 or whatever. It starts at O, because it doesn't say O2, O1. Okay. Okay, maybe something's wrong with your math, I don't know, but when you divide it, you're supposed to get point. Oh, okay. Yeah, that's alright, don't worry. Just make sure you got it right on the test. So that would be unfortunate. But 0.566 divided by 16, because you're just doing O, you should get 0.0354 moles. So once you do that, so now you have the moles of both, right? What are you going to do? What's the ratio we have here? Yeah, mole ratio. So what's the mole ratio we have at the moment? What are we going to do? So, because we're trying to find empirical, right? What do we do to get that? We have both mole ratios. Divide by O because it's smaller. Exactly. So once you do that, what's the mole ratio? 16 from oxygen. And just oxygen alone. Oxygen. Because it says right there, arsenic and oxygen are the only elements. So once you divide, what's the mole ratio? Can anyone tell me? Because O is obviously 1, right? So what about arsenic? What is that going to be? Can anyone tell me? What do you get as 2.1 arsenic to 2.5 oxygen? Okay. And do we all agree with that? Or did we get something else? Do we all agree? Larger than... That's an 8. That's supposed to be... Wait. This, mm, this is... Wait, I think I did... Yeah, it's supposed to be... Sorry. 1.042, my bad. No wonder the math was like a little weird. Okay, that's supposed to be 142, my bad. So once you do that, what do you get? Because Amelia said 2.50, right? Okay, and do we all agree with that? 1 arsenic and 2.5 oxygen? Yes? No? Yes? Okay, yeah. To multiply. Okay, yes, that's what you guys are forgetting. So, once you do that, so if you have arsenic, you can't just have 2.5, right? So you have to keep multiplying so you get a whole number. So it can't be 1 to 2.5. That's what you get immediately, but it's not your final answer. So when you do that, what do you multiply times to get the final answer? 2, exactly. And once you multiply 2.5 times 2, you get 5, right? So the correct answer is what? E, okay. Do we all agree? Do we have any other? And E, any other answers? E. Do you think it's A, B, C, D, or E? Anyone else? Do we agree? Yes, no, I don't know. Yes, no. Just need one more person to say something. Yes, okay, finally, yes. Yeah, I usually have to wait. Like, I want at least 3 people to say their answers at the end. So yes, it's E. We all understand this, right? I think it's pretty easy. Just, again, dividing, just doing all that out. In real time, if you're doing this on a test, it'd probably only take you, I would say 2 minutes, because it's not that deep or hard. It's just a wordy problem, I guess. But overall, the math isn't hard. This isn't that bad, I think. So we're all good on this? But from the looks of Dr. Kelly's questions, she usually has pretty easy ones. So this would probably be like one of her harder questions. Okay. So the correct answer is D, yes. So next one. What percent of phosphorus is in calcium phosphate? So what are we going to do first? We're finding the percent of phosphorus. So just the P. So, and we're given the molar mass, so you don't have to go find it or anything. So what do we do first? Can anyone tell me? This was actually really easy. So what do we do? Can anyone tell me what we do first? Trying to find the percent of phosphorus. What do we do? Does anyone know? What do we start with? What values do we start with? Percent of phosphorus in this whole thing. So just the P, even though it's a polyatomic ion, it should be fine. I actually don't know. Okay. Find molar mass of phosphorus first? I actually don't know. Okay, does anyone else know? Because we're kind of blanking here, right? Molar mass of phosphorus or not? If you're trying to find the percent of something like 15 over 100 or something, that should be a pretty good hint, right? So I think molar mass, yes, and you'd be definitely correct. If you're doing something and it's all out of one thing, calcium phosphate, you're doing the percent of just the phosphorus, right? So what's the value of phosphorus that we're putting on top? Can anyone tell me? What is that going to be? Does anyone know? Looking at, you can just Google it, or if you have your periodic table, you can take a look as well. Does anyone know what that would be? Yes, no, I don't know. When you multiply that out, what do we get for phosphorus? 61.94. Okay, and do we all agree? Yes? 61.94? Did we all get that? Yes? No? I don't know. Answer if you can, please. Is that correct? You don't know. Okay. Well, if you do it all at once, then you would know get that number. Okay, well, Hunter got that number. Hunter, can you explain how you got 61.94? You're looking at phosphorus, right? Do we have 1 phosphorus or 2, or how many phosphorus do we have? 2, exactly. Yes, 2 phosphorus. You take the original, which I think how much? 30.97, you multiply times 2, and you get 61.94. So now that you have grams of phosphorus, what do we put on the bottom? 100. Okay, you're finding the percent of calcium phosphate. So you're not putting 100 on the bottom. You're actually going to put what? Because you're doing percent of what? We're doing percent of phosphorus in the whole calcium phosphate. We have grams of, yes, so it's going to be 310, exactly. Mass of the whole thing. So that's going to be that. So when you do that, what do you get? What answer do we get from that? A, yes, exactly. Did you get, I think you get like 19.999 or something. But then you have to multiply that times 100, right? So you end up getting 20% rounded. Okay, pretty easy stuff, I think. Okay, do we all understand that? I think that's pretty easy. You're just, multiplying the phosphorus all over that. So it's just percent composition, pretty much. Okay, we're all good on this? Yes? Yes, okay. Here's the attendance link again, because I know some people joined a little later, so please sign that if you have the chance. So it's A. Okay, next problem. Okay, if unshaded spheres represent nitrogen and shaded spheres represent oxygen atoms, which box represents reactants and which represents products for the reaction? So shaded is oxygen, and then unshaded is nitrogen. So which boxes represent reactants and which represent products? I'm going to give you guys a second to look at those. This is a conceptual problem, so there's no math involved. Can anyone tell me what that is? B. Okay, we got B. Anyone else? So A reactants, D products. Okay. Interesting. Okay, do we have any other answers? Someone just put B in. Do we have anyone else that has an answer? Unshaded, shaded. What do we think? Working, hold on. Okay. All right. Anyone else? If you already finished. Shaded represents ox. B. Okay. B and D. All right. So do we have any other answers? I just need one more person to answer. Oxygen. B. C. All right. Okay. C. Okay, so we have a little bit of a mixed answer thing going on. Actually, from what I'm looking at, because a lot of you guys said B, right? This is C. C, sorry. Okay. All right. So when we look at this, actually it should be D, or maybe my answer key is wrong, but I believe box C should be the reactants, and then box D should be the products. Because unshaded is nitrogen, right? See nitrogen before. Yeah, I think it should be D. So I'm not sure where B and C is coming from. Maybe the answer key is wrong. Yeah. So yeah, it's supposed to be D. So I was confused why no one got it. But yeah, just make sure you look very closely. Oxygen's 2 shaded, so that's these two. It's supposed to be that. Get it? Because you have NO2, right? NO2. Oh. So 2 shaded ones should be oxygen, and that's the nitrogen one we have right there. Just pick B randomly. Yeah, I had a feeling everyone was going to choose B, because once one person puts a wrong answer, everyone follows through and they put the wrong answer too because they don't know it or something. So, yeah, but it's supposed to be D, and I'm pretty sure it's D. So, again, do we understand oxygen is shaded spheres? That's why there's 2 here, and then that one unshaded is nitrogen. So that's why these cancel out. Like, that doesn't work. This one doesn't work. Yeah. And then D, again, it's the same thing. It's the same thing again. So 2 shaded ones is the oxygen, and then this is the NO. So that's why that's D. Do we all understand why now? Because no one got that right. So, do we all understand why that's D? Yes? No? Alright, yes. Great. Because you guys were making me scared, because I thought this one was easy. So I was like, okay. Alright, so next question. So that you're given this equation, how many moles of fluorine F2 are required to form 3 moles of krypton hexafluoride KrF6? C. Okay, do we have any other answers? How many moles? 9. Okay, so you're changing it to E, okay. So, anyone else? E. E? Okay, do we have any other answers? I'm gonna let you guys do this, like these easy ones by yourself, because I think it's too easy, I think, for me to just go in and like help you immediately. Unless you need help for it, obviously. So, any other answers? Do we agree, disagree? Because T and Amelia both got E. Do we agree? Yes? No? Or if you're confused, I don't know. Anyone else? I need one more person to answer. So, someone please end my suffering with this awkward silence. You don't know. Okay. So for this problem, you have 3Fe or F2, right? And then that goes to 1. Okay. So there's more. 1KrF6, right? So now that you have that, it says how many moles of fluorine F2 are required to form 3 moles. So because you have 1 here, now you need 3. 3KrF6. What are you going to do to the other side to make it equal? What do you have to do? You just multiply times 3, right? You have to add 3. Add 3 or multiply by 3? Multiply, yes, exactly. So 3 times 3, that's going to equal to 9. So that's how T and Amelia got E. So does everyone understand why that's E? It's alright, it happens. So now that we've got that, we all understand how E is the correct answer? Yes? Okay, I'm going to take that as yes. Okay, so we're good? Okay. Yep, that's E. And then, so this reaction, now you're going to find the percent yield, practicing a lot of conceptuals today. I mean, math today. So we have 12.7 Cu produced 38.1 grams of silver. So what is the percent yield of silver in this reaction? Okay, so what are we going to start with? 12.7 or 38.1? You're trying to find the percent yield of silver, right? So what do we start with? 38.1. Okay. Do we all agree 38.1? Yes? No? Yes? Okay, actually, no, you're starting with 12.7.
Why are you doing that?
Oh gosh, this is going to be an interesting test. What's it called? Okay, so, yeah. So the reason you're starting, because 38.1 is actually just going to be, yeah, exactly. 38.1 is the actual yield. So you're not using that until you already found the amount of silver conducted in this reaction first. Yeah, Emily's got it too. Okay, so yeah, this is the actual yield. You have to find the theoretical yield first. Yes, exactly. Yes. So once you found that, so now we have 12.7 grams of Cu. What do we do next? Can anyone tell me? We found Cu, so what goes next? Molar mass. Okay, what's the molar mass of Cu? Does anyone know what that is? Just Google it really fast. Any answers? 63 point, yep, exactly, 63.55. I'm just gonna round that to the thousands right there. Okay, and then what goes on top? So now we have grams of Cu, 1 mole Cu, yes, exactly, 1 mole Cu. So now you have 1 mole of Cu, obviously the bottom has to be the same, right? So you're gonna have 1 mole of Cu, and then what goes on top? Can anyone tell me what comes next? What goes on top? 2 moles of Ag. Do we all agree with that? 2 moles of Ag? Yes, exactly. And you get 2 Ag, by the way. If you're confused from up here, you have to use the reaction in there. So don't just like randomly be like, oh, it's just 1 mole of this. Because I know some people, when I help them with SmartWorks, they think, oh, it's just going to be 1 mole every time, but it's not. It's 1 mole or it's the mole included in the reaction. So please don't forget about that. Yep. So yes. Okay, and do we all understand how that's done? That Ag is 107 on top. We're putting the molar mass, by the way. So once you do that, what's the final answer? What do you get? When you multiply and divide all this out, what do you get from this? What's the final answer? Can anyone tell me what that is? Once you multiply it and everything? 43.11. Okay, what did everyone else get? Did you guys get 43.11? Did you get 43.11? Okay, anyone else? 43.11 or what? Yes, no, I don't know. Again, I need one more person because there's like 14 people here, so it's okay, it's okay. Not sure. Okay, so what part are you confused upon? Hunter, if you're some people don't know, okay. So for this, again, you're just taking 12.7, divide by the molar mass, and then, yeah, you just have to put it in, try multiplying it, 12.7 times 2 times 107.87, and then just divide by 63.55. You don't have to go in order if you don't want to. So just multiply 12.7 times 2 times 107.87, then divide by just one thing, and that should give you the answer. It's much easier than going 12.7 divide and then multiply again. So, did anyone else get any other answer? Because I don't want for either. Yes, exactly. And then Hunter, let me know if you have any problems with that setup. So what do you do next? That's theoretical yield, right? I mean actual yield. Oh yeah, theoretical yield. So what do we do next? Actual or theoretical, exactly. So what's actual? What do we have as actual? Yes, 38.1, right? 38.1 and divide by theoretical times 100, and then what's your final answer? D. Okay, do we all agree? Any other answers? Anyone else? D. Okay. Anyone else? D. Yes, exactly. Yep. D. That's the correct answer. Any other questions, comments, concerns? You're just doing stoichiometry on the CU to get the theoretical, and then anytime they give you values like this, 38.1, and they don't say, oh, it was during an experiment or it was that, then you know that's actual, and that's how you know you're using that at the end. Especially if they give you percent yield of silver, then you're probably just going to find it at the very end. You're going to use the 38.1 at the very end. You won't need it during the other process. Okay, so I think we understand that. It's D. Okay, this one's a longer problem, so I'm not sure how long it's going to take, but which statement is true if 12 moles of CO and 12 moles of Fe2O3 are allowed to react? What is the limiting reactant, and how many moles of what is formed? This one's I think this one's harder, so what do we do first? Does anyone know? Okay, can anyone tell me what we do first? What are we going to look at? Fe will be the product. Okay, so to find that out, what do we do first to find that? Can anyone tell me? What are we looking at to find assign phases? Okay, we could do that, but I think there's an easier way. Assign phase. Yeah, I'm not sure what you mean by that. I've never heard that. But actually, does anyone else know? When you look at this equation, what are we looking at first to find the limiting reactant? Gas or something. Actually, you don't need to know that part, so don't worry. Okay, a class says C. Okay, does anyone else have another answer they got? Or is like A? Okay, T got A, Akash got C. So we have different answers so far. Anyone else want to take a stab at it? Still working. Okay, that's fine. Okay, does anyone else know what's the first value that you start with? Especially the people that already got their answers. What do you get? Okay, so I'm going to help you guys with this because I think you're struggling. We're going to look at CO first, just because. You can start with Fe2 or O3. You just need to look at a reactant first. Looking at 3 moles of CO, we have 3 moles CO, right? And so with that, we have 2 Fe, 3 CO2. And because we have 12 moles of CO, what are we going to do with that? Does anyone know? Yeah. Okay, A. Alright, so with this, because you're trying to find, because you already have 3 moles of CO, you're trying to find the amount that is associated, right? You have 12 moles, so what you're going to do is you're going to go 12 over 3 times 2, right? Because there's 2 FEs. And so that's how you get 8 moles of Fe. Yeah, some people are getting their answers now, huh? Okay, 12 over 3, and then because you have 3 CO2, you're going to multiply that times 3. And once you've done that, you get 12 moles of CO2. And then once you've done that, we can go over, we can do Fe2O3, and you have 1 mole of that. 1 mole of Fe2O3. Okay, and because that's just going by 1 mole, we can just multiply that really fast. So 12 times the 2, right, that we have for Fe, we're going to have 24 Fe. And then on the other side, we're going to have 12 times 3, which is 36, right? So you have 36 CO2. Which one's smaller? Can anyone tell me that? Which one's smaller? Which one has the smaller products in the end? CO or Fe2O3? Which one is it? Can anyone give me an answer? CO or Fe2O3? Which one is it? This one or this one? I'm confused on the setup. Okay, so when you're doing this, you're trying to find, this one's kind of interesting because the reacting is kind of hard, but you're looking at the reactants first that you have. Then from that, you're trying to find the number of products that you'll have using the 12 moles of CO, 12 moles of Fe2, right? Because you have 3 moles of CO, and you have 12 moles. What you're going to do is you're actually going to divide this one, because it's not already by 1. You're going to take 12 divided by 3, and because you have 2 Fe's in the products, you're going to multiply that times 2 to get 8 moles Fe, and that's for Fe alone. Now, to get carbon dioxide, you have 3 carbon dioxides, right? So instead of multiplying times 2, you're multiplying times 3. And once you've done that, you get 12 moles of CO2. And then the same process goes for the 1 mole of Fe2O3. But since it's only 1 mole, you don't need to divide it by anything. It's just going to be times whatever product you have. So it's going to be 12 times 2 and then 12 times 3. So it's going to be 24 Fe and then 36 CO2. Are you okay, Chai? Do you understand a bit more now? Yes? No? And yeah, it is going to be CO. Okay, yes. So once we've done that, what's the limiting reactant? Can anyone tell me what do we get? CO, yes, exactly. It has the smaller products in the end. As you can see, we had 8 moles of Fe, therefore A is correct, not C. So do we all understand this one?
Oh.
Yes? Yes, okay. Very good. Okay, let's keep going. Okay, the mass of iron oxide, Fe3O4, is produced from 2 moles of iron. So what mass of iron oxide is produced from 2 moles of iron? Okay, so we have 2 moles of Fe. What are we going to do first? Can anyone tell me? What's going to be on the bottom? Does anyone know? 2 moles of iron. Moles Fe. Okay, and how many moles of Fe do we have? Is it going to be 1 mole? Or 3 moles? Or 4 moles? Or how many moles? Or 1? How many is that going to be? Moles of Fe.
Is it 3?
3, right? Yes, exactly. Yep, it's going to be 3 because you had to look back at the problem, right? Mm-hmm. So it's going to be 3 moles. And then what goes on top? What are we going to put? Grams, moles? What are we doing? Can anyone tell me? Grams? Moles, Fe3O4. Actually, yep, it's going to be moles. It's not going to be grams because we're looking as of right now, we're not going to go so fast into the mass. We're going to look more at just the moles part. And the reason for that is because you could do mass on top in this specific equation, but I don't want to do that right now because it could always be like 2 and change. So we're going to do 1 mole of Fe3O4, and then it's going to be the same on the bottom, right? 1 mole And then what goes on top? Can anyone tell me? What goes on top of that? And again, if you need to find the molar mass of something, you just Google it. So does anyone know what that would be? What we're gonna put on top of this one? Because we have 1 mole of Fe3O4, right? So what should be on top? Can anyone tell me? Yes, no? I don't know. 2, 30. Yep, exactly. 2, 30, and then you got A for your answer. Okay. So 231.5, 33. So once we've done that, what's our answer? Because someone got 155, Amelia got 155. So what else? Did we all get that answer, or someone else got something else? Because as we see on the previous problems, we don't all agree on everything, right? So did we all get A or B, C, D? What do we get? That was grams, by the way. Got A, right? A, yes, exactly. So, yep, that's correct, the answer. And the reason we don't put grams instead of 1 mole Fe3O4 on top here is because it could always change. It could always become 2, that could be 3. So I don't want, we're fortunate right now that it was 1, but if it was like 2 or 3, your whole problem would be off if we just put grams right there. So just make sure you know where everything's going to be. And always play it safe, by the way. Don't just be like, oh, well, that's 1, so I'm going to just put mass there. Because it could always change. You never know. It confuses people. So, yeah, that's going to be A. And that one's pretty easy, I think. Okay, it's conceptual. Which of the following statements about a chemical reaction is false? And this is 7.1, I believe. So, what do we have? I'm just going to sit back and let you guys answer that first. Until someone says something in the chat. Which of the following is false? D. Okay. What else did everyone ask? D. Alright, D. Any other answers? D. Okay, so the overwhelming majority got D. And anyone else? D? Yes? Number of moles, yes, okay, so yep, that would be correct. The number of moles of products equals the number of moles of reactants. That's simply not true because you can have 2 O2 plus like 2 H3 and have like 1 OH5 or something. Like I'm just making it up. But again, like the moles, like there's 4 on this side and there's 1 on the other. Like the moles, obviously they don't match. They don't need to be because if it's balanced, then it's fine. It doesn't need to have the same moles on each side. No, that's stupid. So I think that one's pretty easy. All got the same answer. So yep, that's D. And then calculate the mass of 6.3 moles of ammonium sulfate. There's not that much in this one, but it's really easy. Once you do the math, it's super easy. So we have 6.3 moles, right? To start, what do? Again, if you want, because I know some people do this, you can solve it individually and then just say your answer in the chat if you hear it fast and you just know it. But what do we do next? Molar mass, right? Okay, what goes on the bottom?
Is it
1 mole, then molar mass? Okay. 1 mole, then molar mass. Do we agree with that? 1 mole. Okay, yep, actually, I understand what you're trying. Yeah, I think you're trying to say what I think you're trying to say. But 1 mole goes on the bottom, right? Because we have 1 mole of this huge thing. So you're just gonna start off with that. So it's gonna be 1 mole on the bottom, and then so forth. So what goes on top? The molar mass, right? So what's the molar mass of ammonium sulfate? You can just Google that because I wouldn't multiply it out periodic table. Won't waste my time at the moment. So what do you get when you multiply that out? Does anyone know? What do you get when you multiply to get that? 132. Yep, 132.14. And then what else do we do? What do we do next? Can anyone tell me? What do you do after you've done that? What goes next?
Isn't the ratio?
Does anyone have an answer? Yes, no? Ammonium sulfate on the bottom. Okay, do we agree with that? 1 mole of ammonium sulfate on the bottom? Do we agree with that? Wait, JK. Yeah, actually, that was a trick question I just asked. There is nothing on the bottom. We already have 1 mole right there. So that's the final thing. That's how easy this problem is. It looks kind of hard at the get-go, but it's really easy.
Oh, yeah,
So once you've done that, what's your final answer?
Because you're trying to.
What do we get? You're just multiplying two numbers, basically. There's only 1 mole on the bottom. B. Yep. T. Dolores. Okay, yep, that's gonna be B. Yep, okay, that's pretty easy, I think. Okay, B. And then calculate carbon atoms. We'll do this one really fast. That tricked me at first. Yeah, this one, it's super easy. Again, like these problems I'm showing you, like with stoichiometry and mole products and like mole reactants, very easy. You just have to cross out the initial units. So this problem, I'm gonna leave you guys to do this first because we just did like 3 of them. So I want to see like what you guys can do from this. And I'll give you guys a minute to do it because I think it's pretty fast. So what are we gonna do? B. Okay, what else did everyone else get? Let's see. So I really got B. I'm trying to find the number of carbon atoms. 1 mole of sucrose. C12H22O11. Okay, anyone else? This one's pretty easy too. It's only like, I think like 2 steps. B. Okay, T got B. Alright, anyone else? Right, because if you don't answer, I'm just gonna assume you're like confused or something. So this one's again like pretty easy. Anyone else? Any other takers? Chad? Dolores? Anyone else have an answer? Confusion once again. Okay. So 1 mole of sucrose, right? You're trying to find the amount of carbon atoms, right? So, but we can't just go from moles to atoms and all this stuff, right? Because you only have 1 mole of sucrose. So you're gonna do 1 mole again on sucrose to cancel out the initial unit, right? So 1 mole of the sucrose, just like the C12H22O11 moles C. Yeah. So then on top you have like the 12 mole. Yeah. You probably got 12 at first. That's why that's there to trick you. But you basically just multiply that times 6.022 times 10 to the 23rd, which is Avogadro's number, and then you would get B. So yep. This one again is pretty easy. Just make sure you don't stop at just 12. Because that's how you get it wrong. You're trying to find atoms, right?
Mm-hmm.
And atoms are rarely just one thing. As you know, it's probably 10 to the whatever. So let's go to the next one. That's pretty easy. How many grams of oxygen are there in 300 grams of potassium oxide? Okay, does anyone know? Okay, I'm gonna let you guys do this one too because I think it's pretty simple. And all of this you're using like limiting reactants. Like if you notice all the problems we've been doing, like percent yield, stoichiometry, chemical reactions, balancing things, whatever, it always uses stoichiometry, dimensional analysis, molar mass. It's like the same concept you guys learned for exam 1 and exam 2. It's just all together in one thing to find other stuff. So you're just using the same skills you already know and just using it to find other stuff like percent yield. Again, you're just using dimensional analysis. Stoichiometry, it's just dimensional analysis. Percent yield, again, like it's all the same thing essentially. So once we do this, what do we get as our final answer? And you also want to round. When you get your final answer, make sure to round it so you get the correct answer. And this is our last problem, I think. So yeah, I think I have one more, but we don't have to do it. So once you get your answer, you can put it in the chat and we can just check over it really fast. This one's pretty easy too, I think. It's just an extended thing. Don't want to say it, but okay, D. Okay, so T got D. What else did everyone else get? D. Okay, everyone else. Let's get like a few more answers and then we can stop right there. Okay, do you have any other answers, takers? Yes, no, I don't know. I'm gonna leave you guys. D, okay. So far we're getting a lot of D. Okay. Yes, exactly. I'm just gonna write it out just in case if anyone's confused and they're just not saying it. So we had 300 grams times K2O and I'm just gonna put it here just because, again, you just have to Google it to find it, but I'm just gonna put it here anyway, save some time. Doing 1 mole of oxygen on top. You're gonna do on the bottom right to cancel that unit. It's 1 mole oxygen, and then we only have 1 oxygen, right? So it's just gonna be 16 grams. And once you do that, you should get 50.9, but once you round it, you'll get 51.1. So, do we understand? Did everyone get that? Yes? I think it's pretty simple, pretty easy. Again, dimensional analysis. So we're all good on this? Yes? Okay. So, yeah, I think that's almost it. Yeah. There was this problem I had. You can do this one at home, I think. I'll probably send this, do you guys want this PowerPoint or you're good? Like, you don't need it? Because I think you guys are pretty good on it. But, like, if you want, I'll send it. But for the most part, I think you're okay. Can you send the test? I wish. Yeah, I do. Can you send it to me? Okay, I actually have a whole, practice test. The thing about your class is that it's very weirdly done. She has, what, like 5 tests or something? So it's like completely chopped up. Because with regular chem classes, yeah, I can send it. Usually, like, we have 7.1 to 8.5, and then you have 21.1. You have all those sections. Your class only goes to 8.1, so it's really short, which is so weird. Because most teachers don't do that. So, yeah, I'll do that. Yeah. Yeah, I don't know. Her practice test, I don't even really look at her practice test. I'm not even gonna lie because I think they're too easy. Like, I was like, these questions are like exam 1, so it's weird. Like, I don't like looking at them. And so that's all.